Good morning, students. Today we are going to discuss on the topic called deadlocks. It is defined as a set of block processes each holding a resource and waiting to acquire a resource held by another process in the set. Example: system has two disk drives. P1 and P2 each hold one disk drive and each needs another one. Example: P0 P1, wait A, wait B, wait B, wait A. System model. Resource types R1, R2, room, CPU cycles, memory space, I/O devices. Each resource type has Y instances. Each process utilizes a resource as follows: request, use, release. Deadlock characterization. Deadlock can arise if four conditions hold simultaneously. They are: mutual exclusion. Only one process at a time can use a resource. Hold and wait. A process holding at least one resource is waiting to acquire additional resources held by other processes. No preemption. A resource can be released only voluntarily by the process holding it, after that process has completed its task. Circular wait. There exists a set P0, P1, P0 of waiting processes such that P0 is waiting for a resource that is held by P1, P1 is waiting for a resource that is held by P2, Pn1 is waiting for a resource that is held by Pn, and P0 is waiting for a resource that is held by P0. Resource allocation graph, a set of vertices V and a set of edges E. V is partitioned into two types. P equals P1, P2, Pn, the set consisting of all the processes in the system. R equals R1, R2, room, the set consisting of all resource types in the system. Methods for handling deadlocks. Ensure that the system will never enter a deadlock state. Allow the system to enter a deadlock state and then recover. Ignore the problem and pretend that deadlocks never occur in the system. Deadlock prevention. Mutual exclusion. Does not hold for shareable resources. Must hold for non-shareable resources. Hold and wait. It guarantees that whenever a process requests a resource, it does not hold any other resources. Require process to request and be allocated all its resources before it begins execution. No preemption. If a process that is holding some resources requests another resource that cannot be immediately allocated to it, then all resources currently being held are released. Preempted resources are added to the list of resources for which the process is waiting. Process will be restarted only when it can regain its old resources, as well as the new ones A requested. Circular wait. Impose a total ordering of all resource types, and require that each process requests resources in an increasing order of enumeration. Deadlock avoidance. Requires that the system has some additional a priori information available. The deadlock avoidance algorithm dynamically examines the resource allocation state to ensure that there can never be a circular wait condition. Resource allocation state is defined by the number of available resources, allocated resources, maximum demands of the processes. Safe state. When a process requests an available resource, system must decide if immediate allocation leaves the system in a safe state. System is in safe state if there exists a sequence of all the processes as the system such that for each pi, the resources that pi can still request can be satisfied by. If pi resource needs are not immediately available, then pi can wait until all pj have finished. When pj is finished, pi can obtain needed resources, execute, return allocated resources, and terminate. When pi terminates, pi plus 1 can obtain its needed resources, and so on.